Let's take a look at a few examples with variables involved. I'm still following the same rules. So in the first one, it's multiplication, so I want to add my exponents, which means I'm going to end up with x to the 1/3 plus 4/3. In addition, the denominators must be the same, and in this case they are. So x, I have to add the numerators. 1 plus 4 is 5, and the denominator stays the same. So the end result is x equals 5/3. Second example is a quotient or division problem. When you divide, you subtract your exponents. So here I will have x to the 5/6 minus 1/6. That will give me x. This follows the same rules as addition. Numerators, as long as the denominators are the same, will subtract. So 5 minus 1 is 4, the denominator being 6. The only thing left to do now is to simplify that ratio. 4 over 6, they both have a common factor of 2, so that would leave me with 2/3. So x to the 2/3 is your answer there. And then the last one, it's a power-to-power rule. So when I raise a power to another exponent, higher exponent, I multiply. However, you might have noticed we also have a negative exponent in there. So the first step here might be to put the entire thing under 1. That in turn switches the exponent to a positive. If we had begun with it in the denominator and it was negative, we would move it to the numerator and it would become positive. Just like changing sides for an equation, you change the signs. If you change the position of any power, it will change its sign. So now I'm just going to continue on with this one, only it will be end result in the denominator. So if you recall, power to power, we multiply our exponents. So I have 5/6 times 2, or 2 over 1. That gives me x 5/6 times 2 over 1. As stated before, the numerators multiply straight across, I get 10. The denominators multiply straight across, I get 6. The only thing that remains now is to simplify. 10 over 6 will become 5 over 3, giving me my answer of 1 over x to the 5/3.